discussing Docker. So before coming to what Docker is, I would like to discuss on two topics, that is virtualization and containerization. So firstly, I'll talk about virtualization. So virtualization helps us to create software-based or virtual versions of a computer resource. So these computer resources can include computing devices, storage, networks, servers, or even applications. So it allows organization to partition a single computer, a physical computer or server into several virtual machines. So each virtual machine will have a separate guest OS, which can be different from that of the host OS. So run different operating systems or application while sharing the resource of a single computer. So let's see how virtualization works. So as we know it as an hypervisor, the hypervisor software facilitates the virtualization. So the hypervisor sits on top of this host operating system. The hypervisor takes the physical resources from the host and then divides up so that the virtual environments can use them. Now, when a user programs issues and instructions to the VM, that requires any additional resources, as the resources I've mentioned before, from the physical environment. The hypervisors puts the request to the physical system and brings about the changes. So this main feature of the virtualization is that it lets you run different operating system on the same hardware. So that is how virtualization works. Next, I'll be talking about containerization. So coming to containerization, it's a lightweight alternative to virtualization. So the main difference between containerization and virtualization is that the uh, this containerization involves encapsulating an application in a container with its own operating environments. Thus, instead of installing an OS for each virtual machine, containers use the existing host OS. So that particular OS is used by all the other containers that runs on this server. So that is what containerization is, and let's see how it works. So each container is an executable package of software that runs on top of this host OS. A host can support many containers concurrently. At the bottom of the layer, there are physical infrastructures such as CPU, disk storage, and network interfaces. Above that, there is a host OS and its kernel. The kernel acts as a bridge between the software of the OS and the hardware resources. So the container engine and its minimal guest OS sits on top of the host OS, as we can see here. At the very top, there are binaries, libraries for each application and the apps that runs on their isolated user spaces. So now I'm coming to Docker. So Docker is basically a containerized application platform that package the application and its dependencies together inside a container so that the applications work seamlessly in any environment, let it be at the development environment, staging, or production. So coming to the key components of Docker, first is a Docker engine. Next is a Docker file, the Docker images, Docker containers, and Docker registry. So coming to Docker engine, so Docker engine is a key or the core part of the whole Docker system. So this Docker engine is an application which allows this follows this client server architecture. So it should be installed inside the host machine or the inside the host machine. So basically, there are three components in the Docker engine. First is a server. It is the Docker daemon called a Docker D. It can create and manage Docker images, containers, etc. So I'll be discussing on what Docker images and Docker containers are later. So next is a REST API. It is used to instruct Docker daemons what to do. Next is a command line interface. It is a client which is used to enter Docker commands. This is next is Docker images. Docker image is a building block for containers. That is the Docker image. Docker images are immutable read-only files that include the source code. It also contains libraries, tools, and dependencies, and additional files that is required in order to run a application. Next is a Docker container. A container is a runnable instance of an image. It represents a lightweight and isolated environment where an application and its dependencies can run. So an image is a setup and a container is a running version of that setup. Images, another example is that images are like templates and containers are the actual running application based on those templates. Next, I'll be discussing on the Docker architecture. So Docker uses a client-server architecture. A Docker client talks to the Docker daemon, which does the heavy lifting of building, running, and distributing the Docker container. Okay. Next, I'll be talking about the architecture. So first, the user interacts with the Docker client by typing the commands in the terminal, such as docker build, docker pull, or docker run. The Docker client is a command line tool which sends commands to the Docker daemon. It can also communicate to the Docker APIs. So the Docker daemon, this Docker daemon is a background process responsible for managing the Docker objects such as the containers, the images, etc. It listens to the request and manages Docker containers on the host system. Um, Now, when the Docker client sends a command to the Docker daemon, the daemon processes the commands. The commands can include actions such as building an image, running a container, stopping a container, etc. If the For example, if the command given by the user is like docker run, the Docker daemon checks if the required image is available within the local system or the host system available locally. If it's not, it will then go to this Docker registry. So Docker registry is somewhere where the Docker images are put. It can be a public registry or a private registry. If it's not locally available in the system, it takes the images from the public registry. So that is how the Docker architecture works. Next is now okay. Next is installing Docker in Ubuntu. So these are the steps to install Docker in Ubuntu. First, we have to update the local packages using the below command. Then we'll give the following commands to install the Docker. So docker.io is the package which consists of the Docker engine. So Docker engine should be installed. And now, in order to start this Docker service, we have to give the below command, that is sudo systemctl start Docker. Then only the Docker service gets started. So in order to check whether the Docker has been installed properly, it should be Docker and the version. So we can see the Docker version there. So we can ensure that the Docker has been successfully installed. There's a small mistake. Really, Docker D is not capital; it's small. Next I'll be talking about Docker file. So in order to create a Docker image, a certain set of instruction is needed. So this Docker file is a script with instructions in order to on how to make a Docker image. So in these instructions, we can find information about the operating system, the environment variables, file location, network ports, and other details needed to run the image. So here I have given an image of a basic Docker file, which consisting of the base image, that is the nginx. This nginx is the server which enables in order to is used to in order to deploy the web contents. So that is why we have taken nginx as a base image. Now this copy command here is used. This is a Docker instructions which is used to copy the files or directory into the so the dot here represents that to copy everything in the particular directory to the nginx directory. So that is what this Docker file means. Next, I'll be talking about the Docker workflow. So first, let's starting to develop and build your application. So first we have to write the code of our choice. Let's say we are making a simple website using HTML, CSS, or JavaScript. Once we have a running application, first we create a I'll be showing a demo for this after explaining. So first, we'll create a Docker file. It defines this base image, and we can add necessary dependencies and copy your application code into this. Necessary dependencies which copies your application code into the image, and specify the command to run where the when the container is started. So next is the building of a Docker image. So using the Docker file instructions, we are able to build the Docker image. So for that, we use this command docker build -t. So this my app is the name. My app is the name of the latest means the tag given. It shows this that we can give different tags. Basically, tags are given in order to show the different versions of the image. We can use different names such as V1, V2, etc. For the tag name. This command is used to build a Docker image. Once the Docker image has been built, next we have to run the container. Once we have the Docker image, we can create and run the Docker container from the Docker image. For that, the following command is run. This Docker run command here, the -d indicates in detached mode. That is, the container runs in the background so that it does not interrupt the terminal. And -p is the port. This 8080 colon 80 means that 8080 is the port on the host machine, and 80 is the port of this container. And we call the image name here. So that is how the container is run. Once the container is run, we can see the website in the port 8080. Now we can manage Docker containers, such as we can stop a Docker container, we can remove a Docker container, we can start a stop container. There are different ways to manage containers. Uh, Next I'll be showing a demo on how to host a website using Docker and nginx. So I've already created a Docker directory, and inside which I have so inside which I have created a Docker file, as I've mentioned earlier, and all the files that is required for the website hosting. So I have three files, mainly the HTML file, the CSS, and the JavaScript file, and I'll show how the Docker file looks. So I have mentioned earlier, this is the Docker file. It uses the nginx to deploy the web contents as a base image. Using this Docker file, we can create an image. In order to create an image, we can use the following command. So now the image has been built. Now we have to run this in order to run. Now we have to run the container. For that, the following command should be given. Now the website has been hosted. I'll show this. So this is the web page that has been deployed. That's all. Any questions?
Hi, if anyone have any questions, please share.
Hi, Vismaya, this is Alfred. So that was a nice presentation, but as a layman's perspective, this is a basic question. So could you please tell us where we should use container or and where we should not use? I mean, like if you could share some different perspectives or use cases like where container is relevant and where container is relevant, like where you should use container and where you should not use container. Could you please share us some thought about it?
Okay. Basically, containers are used in microservice architectures, and mainly when containers are used when containers are highly scalable. So, uh, such as deploying multiple instances of containers are used when I have to, uh, for example, have a basic image. Sorry, I would say in layman terms, I would say if for example different applications that requires the same operating system, different application that requires the same operating, for example I have can implement different web applications in an isolated environment when using containers, using the same OS. And also containers are used in order to reduce this memory overhead. That is because this containers only use the limited resource, so limited memory that is used, that is needed for that particular container. That is where containers are used. The memory is used based on its based on the need for a particular application. So it is not the memory is not fully allocated for that particular application. So in such cases containerization helps, and also it offers isolated environments for applications. So that is where in such cases containerizations can be used. And
Okay, Vismaya, thank you.
Do we have any extension for Docker file?
sorry.
Do we have any extension for a Docker file? For HTML file, the extension is .html. Like that, do we have any extension for Docker file?
uh, Extension for Dockerfile, like dot Dockerfile.
Yeah, yeah, dot something like that. Is there any extension?
It is not necessary that we should use extensions. It's just the when we create the Docker file, it's just the Docker file. It's not necessary that we have to use extensions.
Okay, can you show how to create a Docker file?
Yeah.
Just from the beginning, like
Okay.
open an editor and type something
Yeah,
and
sure.
create a Docker file.
Yeah, sure. Is the screen visible?
Yeah.
Okay. Okay. In order to create the Docker file, just give this command touch. Uh,
So you are using Linux, right? Linux
uh,
system, right?
yeah.
Okay. Um, how so? How can we create on a Windows machine? Can we use the same command, or is there any different way to create a Docker file on Windows machine?
In Windows machine.
Vismaya, could you please open Notepad plus plus or Notepad?
Yeah.
Okay, create a new file and type some blah blah, some sample dummy text. Click file, click save as. Use double quotes. Type Docker file. Save. Not normal text file. Change that. All types. Save. Still, can you remove that double quotes? Still, can you open just Notepad?
Okay.
Some sample dummy text. Use double quotes and type Docker file. Change save type. All files. Save. Yeah, that's it.
So this is a Docker file, right? So we can use this as a Docker file, right?
Yes, correct, Rafik.
We can put our commands here, so it will act as a Docker file. Okay.
Correct,
So
correct,
another
exactly.
question, the file name. We should always put the Docker. This is we should always put this Docker file the same way that that she saved, right? My question is the name for the Docker file.
Yeah, you're right. You're right, Rafik.
So we always use a Docker file as a file name, right?
Correct,
Yes.
correct, exactly.
Okay. Okay. Hmm. Got it. Oh, I have one doubt. Can you show me the slide again and the presentation again?
Yeah, sure.
Uh, there's a, just show me that instruction that which is inside the Docker file. Okay. So I'm just confused. Like what this copy command does.
So the copy command, what it does is that I have, as I've showed before, I'll show with an example. So here you can see I have these HTML file here, right? So what the copy command does is that it takes all the file from here, that is the HTML, all the files I have in this inside the Docker directory to the nginx file. So it will be copied.
Into the nginx, right?
Yeah.
Can you show me that nginx? How can you go to the nginx
Yeah,
and
yeah.
put that ls on that? I want to see what are the files inside the nginx.
Vismaya,
Yes.
actually, this is a Docker file, right?
Yeah, yes.
So you really need to get inside the container to
Yeah.
see the
Yeah,
files, right?
yeah. Actually, that website which is running inside an nginx, right? Right, Alfred?
Correct, correct.
Okay, there will be
Vismaya,
a yeah, there will be nginx configuration for that, right?
correct, correct, exactly. Sudo docker exec -it and container ID. The command docker. Now, could you please check whether the file exists or not?
Vismaya, you forgot to
Execute.
add bin/bash.
At the end. But
Windows Docker media. HTML is a folder. Docker file. Okay. Okay, fine. Can you show me? Can you show me that nginx configuration file?
Okay.
I think it will be on /86.
Yeah.
nginx.
Okay. One. It will be better maybe on a next section for Vismaya to describe all about this nginx config file. So
Okay.
this is where you have here you wrote the instruction for running that website, right? So
Yeah.
yeah, it will be good to have a session for explaining all about the nginx,
Yeah, sure.
nginx and nginx file. So if we are trying to create a web page using Docker, so we don't know anything about this nginx. So we should aware of nginx, right?
Okay,
Or
okay.
is that necessary, right? Alfred?
Yeah.
yeah, yeah. Let me comment on it, Vismaya. Yeah. So, in order to address your question, Rafiq, it purely depends on the user's perspective, like whether to go with nginx or to go with Apache 2. Both are both can be used to host web pages, not web applications. Yeah, but the advantage with nginx is like it's not just a web host alone. It's a load balancer actually. It's a reverse proxy technically, which means like it can host multiple websites, and again Apache 2 also can host multiple web pages using virtual host file. I agree, but still nginx is specifically meant for that, and the routing is more efficient in nginx. Moreover, it's a reverse proxy as well. So as you have rightly said, gaining a knowledge in nginx is very much necessary, and hopefully Vismaya might take a in detail session in the future. Yeah,
Yeah, that's it. Yeah, thanks,
yeah,
Usman.
yeah,
Okay.
yeah.
Thanks, Alfred.
No worries. Yeah.
So thank you. Anyone have any questions? Otherwise, we can wind up. Yeah, I think It was a good section, Vismaya. Thank you.
Thank you.
Thank you, Vismaya. Bye.
Thank you.